Hello, mic check 1, 2, 3. Hey there. So it's Jasu here, back again with another video. So today we are going to cover trie data structure. So in the previous video we have covered the linked list and hash table. So if you didn't know these data structures, which are very mostly important, so do check it out. And in this video we are going to cover this much, such as insertion, deletion, suggestion, and prefix. So those of you guys who don't know what's a tree is, basically, what's a trie is basically a data structure which is used to show values in a tree manner, in a trie manner. Basically we store characters in order to get suggestions and everything. So it is a great way to show characters in a way that we can retrieve it with less time complexity. I hope so. So let's implement without any delay. So these are the things we are going to cover today. Yeah. Okay. So without any delay, as I said, let's start it. So for that we need a class. So let's start with class. Class trie node. Okay, I will explain on the way. Constructor. We will set a constructor which will have this dot children. Children assign an object, and this dot is word end assign false for a boolean data type. So this is much. So this is a trie node. Okay. So basically, this have a children and a is word and true or false. So yeah, as you know, I think we have a constructor which will create a variable. Oh, oops. Okay, which will create a children and is word end is equal to false. Yeah, you can change it. No one is stopping you. Right. Okay, cool. Now what we want is a trie node. A trie class with the constructor of basically here we are implementing the adjacency list. So this, or we can call whatever we want. No one is stopping you. So here we can call, let's say, this dot root as a new trie node. Okay, cool. Now let's perform the first method, so which is insertion. So without any delay, I think I'm being too laggish. So I'll try to reduce it. Insert, and we need a value, right? Now inside insert, we can say what we wanted. We need the current root. So basically, how tries are stored is like this. I will show you. This is an object. Here we have A, and with a set of or new map of another trie. So here if I say hello, or let's say if I do hello, or we can say apple. Yeah, that's better. And we will have new map inside that. So it is like a nested map. And here also we have a new map and like that. Okay, so here apple new map and another object and new map, and here is word end will be true. Here and here other places it will be false. Is word end false, like that. Is word end false. Oops, I missed here. Is word end false, false, false. Okay, I think you got it. So this is how it will be. So if I say like this, root dot children. This is something like this. So if what if another character appears? So for example, a what is another word with app? Uh, like say let's say it is art. So A is here, so we don't need to store A. Inside a new map will be stored, which is R, and a map of this object. And T inside it, inside R, there will be another, and each word N will be true. So this is how it's working behind. I hope you get. I hope you get it. I mean, in the beginning, as a beginner, it is too hard to understand. So I will try to in the next videos. I will try to have a graph or something like that in order to understand it clearly. But now I feel like you got the basic idea, right? It's okay, cool. So if a word exists, we don't need to actually create a new map, right? New map or a new object, whatever you want, right? So let's say, so what for that, what we need, let we need the root node, right? Let current assign this dot root. Then, and we have to iterate for I assign or not value, it's word, right? I assign 0, I less than word dot length. So we have to iterate till the word's length, and I plus plus. Cool. Now what we want is what we can say. First we need to iterate through the thing and check if it exists or not. So if this dot current of word dot I, which in the sense it's checks if there is anything inside its children, current dot children dot word of I. If if it's there, we don't need to do nothing. We just need to iterate it. Or no, if there is not, we can say, let's say I want to create a new node, right? So current dot children of word I assign, I mean assign new. I think it's a trie node, right? We are basically a new trie node. So what about the value? Yeah, it's storing. So I hope you got it. So inside this, as its children, what was that? Oh God, where is? Yeah, here. Find, yeah. I think I have switched. Oh God, everything gone. This much. Idiot. So let me do it very quickly. Let me pause it, and after that I will unpause. Okay, so cool. No problem. Now one is harmed. Okay, so I have rewritten everything here till here. So now with that example, let's see what is really happening here. Okay, don't worry about this. It's because of this. Okay, cool. So imagine if we have this apple inside our children. So this is something like this with the new map, which in the sense new trie node, which have a children, which contains these object. So when we insert it, we don't need really. For what are the things that we needed is first we need to check if it's exist or not. If it's not, we need to insert that. That's how it works. So let's check. Oh, so I think here If it's not exists, it will create. For example, if I add, it will create. Now, if it exists, what we want, we need current. We need to override the current with current dot children of word of I. Cool, not a problem, right? So yeah, this is pretty much it to the insertion. And after this, what we need to do is after this for loop, after the word ends, we need to set is word end as in true because the word is ended right here. So if it's not at the end node, it should be ended, right? And if our test came, uh, a new T will be here inside. No, artist, yeah, inside this. A okay, a new trie node or map or whatever. It will come here like this, and so eastward true eastward end is a great thing in order to understand if the word is ended or not. Okay, cool. So I think that pretty much is it with the insertion. Now let's move on to the deletion part, which is most of us says one of the complicated part. But let's see what we can do accordingly. So in deletion word, you will take the word that the user bloody want to delete, and let's do this using recursion. I mean that will be simpler. Okay. So here, instead of assigning something inside that scope, let's inside that function because if we assign something inside that function, it will declare or declare it off every time we run it. So what is a recursion? Recursion means what? It will run until the base condition reaches, right? So it will call the function until it. So if we declare something inside the function, it will create memory space for every recursion. That's why we are doing here depth assign 0. Yeah, I think that is pretty much. And we need a base condition. Before that, let's see. Yeah, let's have this base condition. If word dot length is equal to depth. Hey, if word is fully iterated, I want to do something. What? I don't know. Let's do after what the base condition. So after the base condition, we need to iterate through all the nodes, right? So in order to iterate, let we can say um, character, character or something like that, and we can call each node or here. Wait, let me think. Okay, so we can call each node of that word of 0 word, right? Okay. Now let's see if it's that exists or not. So okay, so let me do something like this instead of creating node and doing like this. Let's say this dot shall root or what? Yeah, okay. So here we have some problem. We need current too because in order to iterate, we need something to have the reference of the trie node, right? So this dot root assign trie node. Okay. So current dot children of word of I. Okay, cool. Looks great to me. Okay. Now what we want is if If the node does not exist, what we wanted, we want to return something, return null. That's the proper thing. I mean, that's just do like that. Okay, cool. Now it will iterate until if the node is not there, right? And if the length is equal to depth. So at the end, what we need to check, we have to delete it, right? So check, we what we want to check is we want to check here. Let's say if I want to delete art, we will go to art A, and we will get R, and we will get T. So let me give a file space so you can see that it is inside this. Okay, T, it will go to T, and here it's true. So we need to check if is word is not true, you have to return false. If the word is not true, what it means? If the word is not true, which means the word is not ended. If the word end is not true, which means the word end is not true, right? So in that place we don't have to do nothing. Okay, and if it's true, we have to do something like this. So we have to call like this, then only we can access it. Current dot is a word and in false because we are going to delete it, right? And if sorry, sorry about that. If uh, the children's and if it's not have any children's, so what it means if it's not have any children's? So let's say we are deleting R. So R we have, for R we have multiple children's. So if I delete R, these things, everything will go. I mean, if I delete art, oh, sorry. So inside this, we had some artist, right? So we will have artist here. Oh, it will be something like this. I hope you got it. So if we delete T, I mean, it has some childrens, and the word is all ended because there is an art, right? So we need to check two conditions. If it's true, okay, good, no problem. And we need to return something. If current dot children dot size, I think is equal to, if it's equal to 0, we can say that it's okay to be deleted. So that's what we wanted. Okay. Okay, cool. Now I think it should work. And here, now we have to iterate till the node the word. I mean, you have to iterate. If there is no child for everything, we need to delete every of it, right? So let item to delete assign this dot delete of word current, and what else? Oh, we need node and depth plus 1. Okay, cool. And it will return something. At the end, it will return whether true or false. So if it's true, if item to delete is true, we need to delete that, right? We need to delete that thing. So delete this dot delete. Oh god, there is nothing there. What? How can I delete something inside an object? Oh wait, let me think. Mm, current dot children delete word of I. Let's see if it works or not. So we are deleting it and we are returning something. If we have to return something, what we can return, because what we are going to return will be the thing that will come. So wait, what we can do? Okay, so if after deleting, if current dot, yeah, we can write it in the, wait, let me think. Let's say, okay, so here what we can do is, let's do something else. I need to delete thing, but it's not actually deleting. What we can do? Okay, delete node for children, node of children of what? Node of children of uh, word of I. I think it's an array. Word of I. Word of I. Okay. So that should work perfectly. And in order to get the size, I think we need to change this into a map. Then only it will work. New map. Map. Okay, so in order to set something inside a map, so this is called proxy objects. This kind of object will have a set of rules in order to insert or delete or something. Do something, have a set of things. So rather than this, we can do something. Let's current dot children dot has. Oh, so it's provide its own methods. We don't have to do externally. So current dot children dot set word of as key and value word of I, and the next thing is new try node, right? Try node. Okay, cool. So here we are setting, and here we need to get something, right? So this is what we all needed. And in order to get the size, we will get it inside deletion. So we don't need to worry about that. So is word and we will get the size of it. And in order to get it, as I mentioned, dot children dot get of word of depth. Okay, cool. No problem. So, okay. So this should work, right? And here, children of array. Let's check if it's not works or not. Now we need to return if node dot children dot size is equal to 0 and word n should be false. So yeah, that's pretty much it with the deletion part. Now it's time for the testing. It's time for the bug test. Okay, let me close this. Oh, we have written this much codes this far. Okay, const try say new try try dot insert and yeah, sir. Okay, console dot low try. Let's see what is going to happen. Cleared node try. Okay, cool. So the insertion is working properly. Now if I want to go to A, we can say children, try out children dot get A. This must work. Okay, this is not working. Try it out children dot root dot we have root something called root, right? Now this must work, right? Undefined. A is undefined. What about J? Get is something that we can okay. J okay. We can access the J then dot get A. Now this must work. No, we need to follow that thing. Dot children dot I think children dot okay, cool. Now inside A we have a children of S like that. Now let's try deleting just try dot delete. I think there will be an error that we only needed. Error is something that we needed. Yeah, I forgot the iteration part. Did I mess up? Yeah, not index, it's depth. Okay, next eastward and it's not eastward and current, not current. Node dot eastward and right. Okay, I think not node or I think it should be something called current dot current and current because we are passing inside this function so we'll get as current, right? And we are iterating it and we are not updating the thing. So if something is return false, so I think, I mean, from what I have researched, the problem must be here because it's not deleting it, right? Children dot delete. I'm pretty confused this deleting things. That's then also it's not working. Let's check what are the other things. Okay, after a long debugging, I figured it out that it was a problem of so here I only consult before deletion. I didn't consult anything after deletion. So let's see. Okay, so I wasted entire my half an hour to discover that this was here. This must be here. Okay, let's move on to the next thing. Okay, now let's check the suggestion part. So here we will have a prefix or something that will type user will type and hey, I need a suggestion to this thing. So in order to get suggestion for that, we can first of all we need to iterate it and at the end, okay, cool. So let current say this root and for let current or let I assign 0, I less than I plus plus. Yeah, I will explain it along the way. Current assign if sorry about that if uh, the the thing what we can check if it's the word or the letter does not exist you need to return something if current dot children dot get or has let's check has a prefix of this value return an empty array. Else, we need to iterate till it ends. So current assign current dot children dot get, I mean a prefix of I. Okay, cool, not a problem. Now we reached the ending case of that prefix. Now from here we need suggestions. So how can we get suggestions? All the suggestions or all the children's inside that object. So here let me write another function. What is this? Okay. Which will loop the children's. Okay. So this must should need to be recursive. Let children and child. No, we need to destructure it from an array of, I think, not from the object of children current. Oh God, current not children. Okay, cool. So here we will get the thing, and for every children in the sense it's the value. I mean value and the next object. So key value. It is like key value. Okay. Now we will every key we will recursively call this suggestion function. So here we need something called results. Result. So it's an empty function, empty array, and suggestion. No need of this, right? It needs to be a function, right? Let's see. I mean, let's make this as function. Okay, that should work perfectly. Oh, something went wrong. Okay. Okay, value, and we need what we need. Yeah, we need to recursively call this thing. So here we will have the current and we will have the result over. So we'll pass this child node and what we can say prefixed value. So this will be fixed. So we can say prefix plus value, right? So yeah, this should must work. Now here we need a base condition. So if current dot is word end, we need to return this or push the word prefix into the result. So result dot push of prefix and return it. No need to return, but let's see. Okay, now we can call this thing suggestions dot current and prefix that would be called. Now let's have some errors that is pretty common when it comes to my YouTube channel. When it comes to my tutorials, that's how we learn, right? So suggestion no errors that is in the string. Now let's log this thing. We are getting, yeah, we are literally not getting any of these things. Why? So the problem is we are not returning anything. So now let's see. Okay, cool. So Jasser is here. Surprisingly, it works. Now let's say let's do something. Let's say we can do something. Okay, yo, that's working. Okay, so if I do something like this, it should need to be complete. Yeah, it is common in both. So let me delete. Okay, cool. So that works perfectly. So here we have cleared the word insertion, deletion, and suggestion. Now, one more thing what we have to do is the prefix, which in the sense search if the value is exists or not. So for that, let me mention a tag like this. So for search, it is pretty simple. So if you understood this far, you will definitely you can do all by yourself. Search. Search. I hope the spelling is correct. And let's take the current value as in this dot root. And what we can do is iterate among this, and if the word is not ended or if the word is does not exist, which means uh, it, it 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 won't there, right? Okay, for let I assign 0 I less than search, so we will have a prefix which means it's a search, right? I plus plus looks great to me. You can do it in any loops you want. I mean, you can even create your own loop, like no one is stopping you from there. Just try to explore with it. Just do it in recursion and other things like that. So if current dot children dot has prefix of I, if it's not there, what we have to do? We have to return false. But else we have to return true. And here, I mean, we have to iterate it. Current children dot get prefix of I. Okay, cool. Now after this, return current dot eastward end. If it's end, which means the word is exist, or else it is not exist. So let's try false. Let me clear this thing out. False. Now let's see Jasser. This must should true. Yeah, this is true. So this is working properly. I hope you understood everything. I mean, there is not that much. If you don't understand it, try to find other resources or try to rewatch it again. I'm 100% sure that it will work out you to you. It will understand for you. So in what happens in suggestion is I think a suggestion is one of the most complicated part in try, and we have also try iterations such as DFS and PFS. I think so. So you can work on that too, which is a kind of iteration with stack and queue, which is pretty simple. And if you want an external video about that, please let me know. I will super excited to provide you that. So let me after before that let me explain this pretty quick. So here what will it we will iterate till the prefix or till the thing that user is given to us. After that we will loop through that children. So the children will be something like that object of apple that I have given. So inside one object there will be multiple childrens, right? So for multiple children it will run and it will plus it and we'll get the appropriate suggestions as we wanted, which is pretty basic. And if you don't understand it's a piece of cake, no need to worry about these things, like, but you need to study it while completely understanding it. I mean, here the implementation. Now you have to work on your logic. So that's pretty much is from my side, and I'd like to conclude. So thank you for listening this far, and yeah, that's all. And good luck with your DSA preparations, everyone. I mean, there will be a point where everything will make sense. So don't forget to subscribe. That's all from my side.